this first very cell, I am importing the libraries of machine learning that is being used for a linear regression training model. So we are importing pandas for the basically for all the machine learning part, and NumPy for the array part, Seaborn, Matplotlib for visualization, and these are the initial libraries I'm importing. And if I found some more libraries to be imported, I'll import it afterwards. So running the cell, import pandas at PD. You can PD is nothing but an alias that we, instead of writing pandas every time, we do alias certain words with shorter term. So you might be knowing this. Now I'm importing the dataset pd.read.csv pandas. Instead of writing pandas, I've aliased, so I'm using pd.read_csv USA housing.csv. So this is the USA housing dataset. Now what is our aim? So before moving forward with any of the model, your first aim should be what is our target features. So here the target feature is finding the price of the finding the price of the USA housing. So I'll say that this is a target feature. Whatever I have highlighted, this is a target feature, finding the price of the USA housing dataset. So this is our dependent features, that is our target feature. So now visualizing some of the part. So df.head will gives the first 5 rows of your whole dataset, and if we introduce df.tail, this will give the last 5 input of your dataset. So we have around 5,000 rows, and the first 5 rows is displayed by head, and the last 5 rows is displayed by here df.tail. Df is data frame, whatever the data frame we have inputted, or the data set. Now we are taking the information of the data set that has been fed into our that has been loaded in our data loaded in our this cell. So df.info will provide all the information of the data set, like we have the features like average area income, average area house age, average area number of rooms, and average area number of bedrooms, and area population. So df.info will provide all the information of the independent features, like average area income consists of non-null count values, that is it has the 5,000 values and all the values are non-null, that is none of our data in average area income is been allotted with null values. So all are been allotted with some of the either short or uh, limited values. So all are non-null values, and the type of the data that is fed into average area income is float. So this is the information of our whole data set. Now moving forward, describe will describe you the count, basically gives you the statistical description of our whole data set. Now moving forward, df.columns will give you number of columns in the dataset, like we have average area incomes and all these. And for some of the visualization part, I am plotting the pair plot as an Seaborn library sns.pair plot df. So this is the pair plot I'm obtaining from the dataset. So my main aim is to show you the linear regression model. So I'm moving forward with the linear regression part because of time constraint, and I have to do logistic regression as well. So this is the heat map I'm obtaining from the dataset. So annotate is I have true, and this is the matrix I'm obtaining. So now this is the main part. What is x? X is our independent features. Now for regression part, you need to for any of the part you need to know that the dataset should be numerical value. So here we are finding that data is numerical, and this column consists of non-numerical dataset, that is categorical no, not categorical, non-numerical dataset. So and this dataset is none of our importance with the target value, so we are omitting the address part. Okay, so you need to visualize in your mind that what data you need to keep for predicting the output and what data you need to ignore. This is a part of feature selection. I have explained you in the machine learning roadmap. Okay, so this is the x we are labeling. You can label it with any of the variable, but in general we do with x and y. Y is for outcome output, and x is for input features. Now importing the model selection. Now for splitting the data set into train, test, we basically call sklearn library with model underscore selection parameter that split our dataset into train and test. Now we are splitting the dataset into train and test with test size equal to 40. That means our test data set will contain 40% of overall data. That is, test data will contain 40% and training data set will contain 60% of the data. And random set is like I'll explain more about random set in later stage because it will consume much time. Now x and y we have inputted with a test size of 0.4. You may keep it as 0.3 also, no problem. And random set 42. So let's execute the cell, this one. Okay, so now since we are demonstrating the linear regression model, so we are calling the linear regression from sklearn library, importing linear regression. So this is the syntax of importing linear regression in our row. So excuse me, so linear regression, we have assigned one variable lm equal to linear regression and fitting our model in, fitting our training data set of x train and y train in linear regression model. So after fitting, we are like I said before that linear regression is based on the best fit line where you will be given y is equal to mx plus c in general, where m is the slope and c is the intercept, or we can say as b naught also. So we are getting the intercept of minus this value. Okay, and moving forward with the coefficient of the data set. Coefficient is what? Intercept of all, no? So we are getting the coefficient of coefficient is what? If we are having the x1 x2, that is one variable with the pre value to the variable assigned, that is 24a1. So 24 is the coefficient. So we are getting the coefficient of all the input variables, and here we predict using the, now as I said that we can predict it with trained dataset also and test dataset also, but for better accuracy we are dealing with test dataset. So this is the syntax of prediction of what we have fed into the dataset. So prediction will give you, now this scatter plot is very much important while you visualize that whether your prediction is accurate or not. So we are seeing here that we are getting a straight line, almost a straight line. So we can figure out in mind that okay, our prediction is somewhat what we are, what we need. So now plotting the disk plot. So here you see that we are getting normal distribution here. So the value, so here the plot is like normally distributed. See my cursor going up and down. So it is normal distributed graph. So we are now very much confirmed that okay, our prediction is going in a positive direction. Now finding the matrices. Now what is mean absolute error, mean square error, and root mean square error? These are the variables. These are the features you need to have it while dealing with linear regression. So I'll explain this in the later stage, but as of now, what is ME? So you are getting an ME of this value and MSE as this value and this. So what okay, so what is the accuracy of the model? So here we say that the prediction is almost linearly. So let me find the accuracy of the model. Wait a minute, I'll figure out. So it's not compiling, I guess. So I'll explain you orally. So whenever we find the prediction of the model, we do find the accuracy, and in this which I retrained before, I got an accuracy of around 86%, which I guess whatever we have trained is good enough, and 86 accuracy is good to go with. So this is the concept of linear regression model. So in linear regression, as I said, we import the linear regression model with this import linear regression, and whenever we have to train the model with linear regression, we do assign with some variables to either fit the dataset, train the dataset, or predict the value of the final outcome. So this is the demonstration of linear regression, and if you find any doubt, you may ask now in the comment section, or you may ping me in the Discord. I'll figure out. And now I'll ask again about the queries, and if not, I'll move forward with the logistic regression. Anyone having any doubt, you may unmute yourself and share what is your query, and I'll